conversion from lines of code to function point analysis is called as one way, and function point analysis back to the lines of code is called as backfiring. Factors or criteria considered for the metric analysis, that is the function point analysis. One function point is equal to 100 lines of code in COBOL language. Hello everyone, it is Dr. Ravi Kumar YB. In today's session, let me talk about the project manager who is involved in function point analysis. In the previous session, I was discussing about the function point analysis in terms of general. Now let us see how the project manager who manages all of these projects assigned to the team members and how he is going to analyze in terms of function point analysis. So for this, let me take you into the details of lines of code, that is LOC. LOC of an application can be estimated from function point analysis, FPs. That is, they are interconvertible. The word interconvertible indicates that LOC to FPs and FPs to LOC. That means if you want to measure the metric in terms of lines of code, you can do so. At later point of time, if you want to assess the metric in terms of function point analysis, you can do so by converting from lines of code written by the developers for the entire project. And from the function point analysis, you can reconvert back to the lines of code. So this is called as an interoperability, that is interconvertible. This process is known as backfiring, also known as backfiring. This process of converting from LOC to function point analysis and from function point analysis to the lines of code are called as backfiring. Similarly, if you fire any bullets, let me take up one of the examples of a firing pistol. If any firing is done, if the bullet is fired, immediately the backfiring takes place. That is, the action and reaction takes place. In the same manner, conversion from lines of code to function point analysis is called as one way, and function point analysis back to the lines of code is called as backfiring. So we have these concepts here. For example, one function point is equal to 100 lines of code in COBOL language. That is, 100 lines of code is equal to one function point in case of COBOL language, COBOL programming language. Then, function point metrics is used mostly for measuring the size of management information system. That is, the management information system is going to be tracked with the help of this function point metrics. So if that is the case, how the management is going to consider the software metrics in terms of function point analysis is going to be explained in the form of formulas which we have to calculate the function point analysis in the next and subsequent slides. That is, the function points obtained are unadjusted function points. What is the meaning of unadjusted function points? What is the meaning of adjusted function points? In this case, if I'm able to convert the lines of code to the function point, I'll call this as an adjusted function point. The one which is not possible to adjust, then it is called as an unadjusted function point. That is called in short UFPs. That is, the subsystem are further adjusted by considering some more general system characteristics, GSCs in short, that is general system characteristics. There are 14 general system characteristics available that is considered to convert from any LOC to function point, that is lines of code to function point and function point to LOC. So if that is the case, what is the first criteria that is going to be used for measuring the GSCs, that is general system characteristics? First one is degree of influence. It scales from 0 to 5, that is this. If particular GSC, that is general system characteristic, has no influence, then its weight is taken as 0, and if it has a strong influence, then its weight is considered as 5. That is, as I have already told you, that the weight characteristic, that is, it weighs from scale of 0 to 5. Suppose if it is not contributing towards the metrics consideration, then we say that the degree of influence is 0. Otherwise, if it is strongly contributing towards the assessment of metrics, then we say that the degree of influence is 5. In between 0 to 5, there is also a possibility, that is the percentage of degree of influence that is going to be affected with respect to the characteristic, that is function point metric. Then the score of all 14 GSCs, that is 14 general system characteristics, is total to determine the total degree of influence, also called as TDI. I am using the first one, that is DI, degree of influence, then second one, total degree of influence. Then we have the value adjustment formula, that is the value adjustment factor. This value adjustment factor is defined by this formula, that is TDI, total TDI, that is value adjustment formula is equal to TDI, total degree of influence star 0.01 plus 0.65. As you all know that this is the smallest value, minimum value I can consider here, and this is the maximum value I can consider here. In the previous session, I have explained you about the minimum and maximum value, that is the range of minimum and maximum value that can be considered for this. Then we have the next term, that is the value VAF lies within 0 to 0.65 to 1.35, because the total degree of influence is 0 when the value of this value adjustment factor is equal to 0.65. When it is equal to 70, it goes to 1.35. That means 0.65 is the minimum value and 1.35 is the maximum value. If that is the case, what is UFP? Unadjusted function point. That is VAF star unadjusted function point gives me the function point, final function point analysis or function point count. If that is the case, how UFP is going to be calculated? See here, VAF is value adjusted factor. Then how we are going to find out the function point analysis means VAF star unadjusted function point, that gives me the function point analysis. So if that is the case, let me take up one of the example wherein you will see that the user inputs are is equal to 24, and we have 24 user inputs and 46 user outputs. The inquiries are equal to 8 and the number of files equal to 4. Then the number of external interface equal to 2, which we have already seen in the previous session. That is factors or criteria considered for the metric analysis, that is the function point analysis. Then this is the effort, 36.9 persons per month. Technical documents considered are 265 pages. User documents are considered as 122 pages. This is one of the example considered here for calculating the function point analysis. Cost of this is $7744 per month. So the various processing complexity factors are this. This is the complexity factor I am going to consider here. With this, I have already explained you about the external inputs and external outputs, external inquiries and internal files and external interfaces in the previous sessions. The same criteria are going to be considered for assessing the function point analysis. That is 24 is the external input, that is this. user external input. Then we have external outputs produced by the user, that is 46. Then external inquiries equal to 8, and the internal files are equal to 4, and external interfaces are equal to 2. So totally we have count of this star weighing factor. What is the weighing factor? Let me clarify you that 4 is equal to 96. That means 24 into 4 is equal to 96, right? Then we have 46 into 4 equal to 46 into 4 is equal to 184. Similarly, 8 into 6 is equal to 48. We have 4 into 10 is equal to 40 is equal to 40. 2 into 5 is equal to 10. So if you observe this, 24 is placed as it is here, 46 is placed as it is here, 8 is placed as it is here, 4 is placed as it is here, 2 is placed as it is here. So what is the weighing factor? The star indicates that the count star the weighing factor. This is the weighing factor. Please understand carefully, that is the external user input is 4. This is the weighing factor I am considering. 4 is the external. This is the standard benchmark value we are going to consider for external user input. Then external user output we are assigning 4. Then we have internal files, that is in external inquiries we are going to assign 6 as a standard value. Then 10 as the internal files, then 5 as the weighing factor for external interfaces. Suppose if you have any other values in these places, this remains the same, this remains constant. This may vary, these values may vary, but this doesn't changes. This is the standard benchmark constant values considered for calculating the total values that is generated, that is for this total count, which is equal to 378. If you add up all these values, you will get the value 378. Next, I am going to use the sum of all these function point analysis values, that is 43, that is criteria 1 to 14 is considered here. For criteria 1 we have, that is 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So totally we have the 14 terms here. The function point analysis is equal to 0.65, which is the formula, standard formula I am going to use. 0.65 plus 0.01 star f of I, that is summation of I, that is 4 plus 1 plus so on up to equal to 43. So this turns out to be 43. 43 into first this addition is performed. Since we have the multiplication as a top priority operator, so 43 star 0.01 is calculated, then it is going to be the value 0.43. 0.43 is added with 0.56. As a result of this bracketing operation, we will get the value 1.08. 1.08 is multiplied with 378. That turns out to be the value is equal to 408. Then this is called as a function point. Function point is 408. Then what is the effort which you have already seen in this? See here, efforts equal to 3636.9 persons per month. So this is going to be considered for calculating the productivity. What is the productivity in that particular month? What is the efforts applied by the programmers for completing the software? So function point divided by efforts, which is the formula I have considered here to determine the productivity. What is the progress of that is going to be calculated. That determines which is equal to 11.1. So we have the total pages of documentation is equal to technical documentation plus user documentation. As I have already discussed with you, that is the technical documentation includes 256 pages, user documents includes 122 pages. So totally it turns out to be equal to 365, 85, 89. 387 are there. So which includes both the technical documents as well as user documents. Technical documents are the documents which are maintained by the programmer at the time of collecting the information from the client, and user documentation are the documentation which is the requested by the client to the software developer. So both are considered here for calculating the total number of documentation. The total number of documentation is equal to technical documentation plus the user documents are considered here to calculate the total number of documentation. So at the time of delivery of these software products, all these verifications and validations are done by the testing team. So they are going to consider all these kinds of what is the criteria mentioned by the, which are the criteria mentioned by the client, and which are the criteria that have been met by the developer. All those things are going to be cross-verified at the time of delivery. Before it is going to be delivered, it is going to be cross-verified. Then we have 387, that is the documentation. 387 pages are there, but what is that? 408 is the value which we have obtained for the total count, that is the function point. Function point divided by efforts gives the productivity, but function points divided by function point is 408, 387 is the documentation. Out of this, that turns out to be 0.94. 0.94 means 94 into 100. 0.94 into 100 is equal to, that is this. It is not multiplied by 100. It is 0.94 percentage of documents information, documentary information includes comments of both of clients and technical team. So the cost divided by productivity. I am just cost per function. In order to calculate the cost per function, I am going to consider the cost divided by productivity. What is the productivity we have? Productivity is equal to 408, which is defined in the previous slide. That is productivity. 408 divided by 36.9, that turns out to be the value 11.1, which is going to be used here. 11.1. What is the cost of that? Total cost, that is $77.44, $77.44, which you have seen in the previous slide. That is in this. Cost is equal to 7744. So I'm going to consider that value. So which turns out to be the value 700. That is cost per function. For one function, the total cost of expenditure is $700. So this is how we are going to calculate that. Then what is the difference between function point analysis and lines of code? These are interconvertible, but there is some difference between the function point analysis and the lines of code, because at the time of interconvertibility, these function point analysis and the lines of code gets difference. So the function point analysis, FP, and lines of code are considered here. Along with that, the unadjusted function point analysis is considered. So see to it here. Function point is specification based. Lines of code is an analogy based. This is specified by the client. This is specified by the programmer. So the function point analysis is also analyzed by the manager, which includes both client information as well as the technical documentation. So function point is a language independent. This LOC is a language dependent. How it is going to be language dependent? It is going to be converted from one language to another, of course, but it is dependent on language. If I use the Python language, I can solve any of the task in 10 to 15 lines of code. Suppose if I want to achieve the same task in C programming or in C++ programming language, I may have to write down 50 to 100 lines of code to achieve the same task. So that depends on the programmer to programmer, and the efficiency of the programmer defines the lines of code. Then function point is language independent. It can be converted easily from function point to LOC and LOC to function point. Then function point is user oriented, that is the client oriented. Then lines of code is design oriented. That means it is going to be designed by the programmer, so it is called as a design oriented. It is function point is extendable to lines of code. That is, interconvertible is possible. It is convertible to function point. That is backfiring. So we are going to have this kind of information, so that the information from function point analysis to the lines of code and again backfiring is possible, so that the managers who involves in analyzing the efforts applied by the developers and what is the progress that has been achieved during the process of software development, everything can be analyzed by using the metric called function point analysis. We have two metrics, one is lines of code and the other one is function point analysis. So with this, I'm going to conclude this session. Thank you very much. Thank you one and all.